Welcome to Java with Meenu Jaiswal. Let's continue our discussion on streams. From filtering to slicing, map to a flat map, how to find and match. We shall cover everything in this video. So without much delay, let's get started. Let us start with the filtering. So as we have seen in the last video that streams support internal iteration. So how does that internal iteration is possible with streams? So mainly with we use like the filtering operations, filter, collect, right? So these help stream with the internal iteration. So coming to filtering with predicate, okay, a filter uses a predicate. So if we see this example, so we have, suppose we have a menu object, list of items in a menu. So we are creating a stream of that, and then we are filtering the dishes, only the dishes those are vegetarian. So here we have used the method reference way of calling it, of defining the lambda expression for that predicate, right? So we have used the method reference. So we are filtering the stream. So only the vegetarian dishes we are filtering out here, okay? And then collecting in the form of toList. So if we see the internal iteration working of this, so suppose we have a menu and we have created a stream, okay? Consider these green ones as vegetarian dishes, okay? So when we apply filter, what happens? So only those, a stream of dishes is returned by the filter method, which takes a condition or a predicate as input, and it filters out the given stream. So this stream, it filters out based on this predicate, and then it returns another stream of that object, right? So it returns another stream. Now this stream, we apply the terminal operation collect to collect it in the form of a list. Okay, so we will have finally the list of dishes that are vegetarian. Okay, in this way we can apply filter by using a predicate, right? So this is mostly used, and this is very much used when we are handling collections and when we are manipulating the data and all. So filter is widely used, and it's good to know how it functions, right? Coming to distinct, right? So suppose you have a list of integers and you want to filter out only even numbers from a list, and also make sure that there are no duplicates. Okay, we want kind of a set kind of behavior. We want unique elements in that list of integers. Okay, so here what are we doing is, so here we have taken a numbers string, right? And we are filtering. So here our condition, here our predicate is I, each number divided by 2, and the result should be 0, right? So that means it is an even number. So this returns, this applies on each of the elements in the string, and it filters out only the numbers that are divisible by 2 to make sure those are even numbers. And then we get a stream of integers, and then this stream of integers we are converting, there is another condition that there should be no duplicates, right? So here what we are doing, we are applying this dot distinct, right? If we apply dot distinct, then this 2 that is repeating twice here, so it filters out that, and it gives us unique elements. So we will get a stream of integer that has the unique elements, and then we are printing it out, right? So this will print out the 2 elements which we got filtered out from the list of integers. Okay, in this way we can apply filter and then distinct. Next, there is another way in which we can work with streams and internal iterations. So one is we call it as slicing. Okay, we want to reduce the or limit the output which we are getting out of a stream. So in that case, we can use limit as well as skip. So let us see the working of these. So suppose in our menu stream, okay, we are filtering the dishes which are having greater than 300 calories, and then we get those filtered dishes, and then what we are saying is, I just want only 3, okay, not more than that. I just want only 3. So, and we are collecting these in the form of a list of dishes. So now, as we have seen in the previous video that if we say limit 3, so as soon as the 3 elements are received, the filter stops filtering more elements. Okay, even if we have more dishes here, those have the calories greater than 300, the filter will not continue doing that. Okay, once we get the top 3, then it will stop processing the stream further. Similar to this limit, we have skip as well. Skip means is like skip initial some elements, like skip the first 2 elements or skip the first 3 elements and then give the result. Okay, so here what we are doing is skipping skip 2. So it will skip the first 2 results and then it will give the third and the fourth result. Right. So I have not used skip a lot. So if you guys can tell me what would be a very good example why we would need this skip, do let me know in the comments. Right. Let's move on to mapping. Okay, so filtering is pretty clear, but mapping is a bit confusing. Okay, so for that, what we can do is imagine each element, variable or attribute in a stream as column name of a table. So if you work with SQL, we know that we can select a particular column. So suppose if we have some name column, instead of asterisk we use name, right? Select name, some column name we give from the table so and so. So what you can do to grasp this concept is, imagine that each attribute or the variable or the element in that stream as a column name of a table. Okay, and just like that we have map in streams, and what we do is individual element of a stream, we take individual element of a stream and create a new version of it. Okay, so suppose if we have list of integers, so here suppose if we have list of integers, so what map function does is it takes each input, applies some function, and then creates another version of this one, okay, based on that input, and then it takes the second one, applies something, and then creates that version of it after applying this. Okay, so by creating a new version of it, but it doesn't modify the existing one. Okay, this 1, 2 and 3 it is not modifying, it takes them, applies a function, and then transforms them into a second version. Okay, not modifying the current one. Okay, so as I said, applying a function. So map takes function as an argument. So its input is some function which it has to apply to the element, right? So map takes function as an argument, and this function is applied to each element to transform that element. Okay, so let us see this with some examples. So as we have seen, we have a list of we have a menu which is nothing but the list of dishes, dish object, list of dish objects. So what we are doing here, we want to just get the names of the dishes that we have. So we are creating a stream and then mapping. So this stream, so this menu here is nothing but it is a list of dish object. Okay, so menu is nothing but list of dishes, and we are creating a stream of that, and then each dish we take and we are getting a name of it. Okay, dish 1, name of it, dish 2, name of it, dish 3, name of it. So in that way, it will map each element in this list of dishes to its name, and then that names we are collecting in the form of a list, right? So in this way, we use the map function. And here the map takes a function as an argument, and it outputs a stream of something. Okay, a filter also outputs a stream of something. Map is also outputting a stream of strings here. Okay, we are doing the get name, so get name returns string, so that is why map is returning a stream of strings. So this is very important. What is the return of our map which we are using? Okay, it is a stream of what? So that helps us in writing and in using this map function effectively. Okay, we need to know what argument, what function we are applying, and what stream we are expecting by applying that map. Okay, so let us take another example. So here we have a list of words. Okay, we have a list of words. These are the words, and what we are doing is we want to know the length of each word in this list of words. Okay, so we are creating a stream, and then we are taking each element, the Java 8 first, then we'll calculate the length of it, then the next string, length of it, next, length of it, and the last one, length of it. And all these lengths we are collecting as a list here with this terminal operation. So here, what is the output of the map? So here the output of the map is stream of integers. Okay, because we are this function gives away length, that is an integer, as the output. So we have the stream of integers as the output of this map, and then we are collecting it in the form of a list. We have taken name here. In the first example, we have taken the length. Now what length of some strings. So now what we are doing is combining both the examples, like name, get the name of each dish, and the length of the name of each dish. So what we can do is we can chain this map function. So first we got here the stream of string, right, all the names, and then this stream of string it takes, and then again to each string it will calculate the length, right? So here also the output will be stream of integers. The output of this map, would be stream of strings, and then we are collecting in the form of a list, right? The dish name lengths, just an example. I don't think that will be of any use, but just an example. So let us move on to a practical example of FlatMap. Okay, why a FlatMap would be necessary. We will see how we can achieve this, and why we need to use this FlatMap at all, in what scenario we can use it. Okay, so we will do it with a simple example. Okay, so consider we have a list of string, we are naming it as words, and then we are like having just two strings in that, hello and world. Now what I am saying is, okay, so we want the distinct characters in these two strings. Okay, so what would be the result? H, E, L, O, W, O, O is already done, R, L is done, and D. Okay, so what we are saying is this should be the output. Okay, we want the unique characters in both the strings combined. Okay, so now we can use map, and then we can use distinct for this, right? We want distinct elements, so that will be our first approach. So let us try doing that. So we will first create a stream, and then map each. We'll kind of split, those are strings now, right? So each string, so each word in this list of words we will split, split at empty character so that we get array like the characters individually. And then what we can do, we can call distinct, and then we can, suppose if we want to collect in the form of list. Okay, in this way we can do it, right? But, and what we are expecting here, we are expecting list of strings, because each string we split it. Let's name this list of strings. But is this really a list of string? Right? Is this really a list of strings? So let us see what is the output of map here. So here the output of map is a list of string array. Okay, it is not a list of string, because what happens here is, so let us see the diagrammatic representation of what is happening here. Okay, why it is not list of string but it is list of string array. So what is happening here is, yeah, so if we see here, we have taken hello and world, okay, and we have applied the split. So now what happens, hello is split into its individual characters, and then world is also split into its individual characters. So now we have stream of, the output of that map is stream of string arrays, right? This hello is a string array, and this world is also a string array. And then we are doing distinct on it. Okay, so distinct is being applied on, this is the first array, this is the second array, those two are distinct. So the output of distinct is same, right? Internally we are not applying the distinct, we are applying the distinct on this string, each of these string arrays. So out of these string arrays, this is the first, this is the second, and both are distinct. So that is the output we are getting from distinct, that is also a stream of string arrays, which was not our intention by the way, right? And then we are collecting as list. So it's just that these two array elements we are collecting into a single list. But did we get our intended result here? No, right? So then what we can do? So so this is now string array, right? So in arrays we have the stream method that gives a stream of string. Okay, this is what we want, right? From our string array we want a stream of strings. So see this example. So here we have a string array, some words, and arrays dot stream, it takes the string array as input and then it gives away stream of those strings. Okay, it takes a string array as input and then it gives stream of string. So this is what we want here in this example, right? We want a stream of string of these string arrays which map is giving us. So now let us try to apply this to that map. So what we'll do again, words dot stream. So let me copy this and then I'll change that saves some time for us, right? So now here we can add dot map arrays, arrays string. Okay, I'm using the method reference way of giving that lambda expression or the function. Okay, so what we are saying here, we are saying is this output is stream of string array, right? So this string array should be taken as input by these arrays and then we are expecting a stream of string. But is that really happening? We are expecting it to be this, right? Okay, but is it giving us that? No, because this map now, instead of returning a stream of string that we want, it returns stream of string array. Okay, so if you see this map, so it will return a stream of string array, a list of stream of string array. Okay, we have collected that stream in terms of a list, and this map is giving us a stream of string array. So how do we solve this problem now? Right, so here comes the flat map. Okay, so what a flat map actually does. So by using the flat map, it has an effect of mapping each array not with a stream. So each array not with a stream, but with the contents of the stream. So what it will do is, it will replace each value of a stream. Okay, it will replace each value of a stream with another stream. Okay, here also we will get in flat map also internally it will have stream of streams of string arrays, and then once it generates this, then it concatenates all the generated streams into a single stream. So now flat map, what it does is, the stream of stream, it converts into it concatenates all the streams and gives us a stream of string. Okay, so let us try doing that now. Okay, I will need this same thing. Let us remove this part. No spelling mistakes, by the way. Right. List of strings. So now instead of a map, we will use a flat map. Okay, as simple as that. Now instead of a list of string, we will have our desired list of string. So that is the magic that flat map does. Okay, it takes a stream of string and then it maps each value of a stream with another stream. Okay, it will take each array. Here it takes each string array and then maps it to another stream. So it is creating streams here. I will show that in a diagrammatic format, just a minute. And then it will concatenate all the streams. Okay, so if we see that in a diagrammatic form, okay, so what is happening here is, so first initially we have given two strings, okay, and then we are splitting. This map was giving us a stream of string array. That's where the problem started, right? So now this flat map, what it does is, it each value of a stream, okay, each value of a stream with another, it will create a stream of that. Okay, it creates a stream of each value. It creates a stream and then it concatenates all the streams and creates one single stream. Okay, each value of a stream with another stream. It creates multiple streams and then it concatenates the streams and forms one single stream. So earlier when we were not using a flat map and we were using just map, what we were getting is, we were getting a stream of streams, right? Okay, so we were getting it in the form of like, consider this as a stream, and then LO. Let me write them a bit far. Yeah. Okay, this is one stream. This is the another stream. That was the output. Sorry, my handwriting is not good with this tab. And then we were getting an outer stream, right? And this was in the form of an array. So this was the output without the flat map, by just using a map. So we were getting a stream. This is the inner stream. This is the inner stream. This is the outer stream, and this is the sorry, this is also the inner stream, and this is the outer stream. We were getting an entire stream of streams of string arrays. So now what this flat map does is, each value of a stream, so this is the first stream, right? It takes each value of the stream and then creates another stream. So it creates multiple streams, right? Now it is creating multiple streams of each value of the stream, and then it concatenates all of them into a single stream. So it's like flattening a stream of string. Okay, as simple as that. Now we have a stream of strings, and then we are applying the distinct, then we are getting the distinct. So in this way, so whenever we have a map function where we are expecting a stream of something, but we are ending up with a stream of stream. Okay, that is where that is when we can use flat map and flatten this stream of stream into a single stream. You can work with more complex examples, and that will be more easy. So I have taken a simple example to explain this. Right. So now let us look at some questions. The first question, you can pause the video and try to solve this using the map concept which we have seen, or the flat map if that is applicable. Okay. So the first one, given a list of numbers, okay, you have a list of numbers, how would you return a list of square of each number? Okay, so for example, you have 1 2 3 4 5 and you want 1 4 9 16 25. So this is clearly a map operation, right? So what we are asked is they need the square of each number. Okay, so this is something that we have to operate on each element of this list, right? We need to find the square of each element. So when we have to do an operation on each element of a list, that is when we should be using a map. Okay, so let us try to solve this. Let me use the same method here. So we have a list of integers. I hope you also tried it. So we are just, what am I doing? Okay, we have a list of integers, and then we need another list of integers which is nothing but squares. So we will create a string, right? And then we will map each number with its square, and then we want to collect this in the form of a list. In this way we can solve that question. Okay, now let's move on to the next question. So now we have two list of numbers. Okay, two list of numbers, and how would you return all possible pairs of these numbers? Okay, so this is like you can create some two different maps. Okay, so for example, you have a first list. This is the first list 1, 2, 3, and this is a second list 3 and 4. And what we have been asked is return all pairs of numbers that are possible, right? So 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Okay, and what they are saying is you can represent a pair as an array with two elements. Okay, this is like array 1, array 2, array 3. Okay, so now how do we do this? Right, so here each element we have to map with two other elements of another list. Okay, so can we use a map within a map here? Let's try doing that. Okay, so now I'll just take this as my first list, list 1, and here we just have 1, 2, 3, and then we have a second list where we have just 3 and 4. Okay, and what is our expected output? Okay, once we start working backwards, that is when it becomes easier. Okay, so we want a list of integer arrays, right? This is array 1, 2, 3. So we want a list of arrays, and those arrays of type integer. So we want a list of integer arrays. Let's call it pairs. So first let us take the first list and create a stream of it. Then what we can do? Okay, we can use a map. Why does it show arts? Map. We are trying to apply some function here, right? So we will take the first element in this list. Okay, suppose we are taking 1 here, and that 1 we have to map with 3 and 4, right? So we will take list 2's stream here, and then we will map. It's kind of a nested for loop you can consider. We take the numbers in the second list now, each number, and then we will create an array of I and j. Right? So this map is ending here, and then yeah, so there is some problem here. Let us see what that problem is. So here we will get as in the last example we have seen, we will get a stream of integer arrays, right? When we are creating another stream and then mapping, so this map will also return a stream, and this map is also returning a stream. So it is a stream of integer arrays. So instead of that, that is why we can use a flat map. Why I have used this? brackets, one sec. Right. So if I remove this, yeah. So now this map is returning a stream of integer arrays. This list is coming because we are collecting it as a list. So this is stream of integer arrays, and to convert it into a single stream, we will use a flat map and then collect it as a list. Right? Let me know if you have any questions here so that we can go in more depth. Okay, I believe this should be sufficient. Okay, and then the next question. How would you extend the previous example to return only pairs whose sum is divisible by 3? Okay, so this we can do in two ways. Okay, one is get the final result which we have from the second step, and then do again an operation on that final list. Otherwise, what we can do is, in the same list of pairs, when we are doing the mapping, why not let us write it again. This is really confusing. Just renaming it. So flat map. So we will take each number from the first list, right? And then we are creating a list from the second string, and then dot here itself we can filter out, right? We will take each element from the second list and then we will do the sum of both of these numbers and see if they are divisible by 3. I believe that was in the question. Okay, once that is filtered, and then we can map that element to an integer array of I and j. Right? Where did that go? Oh god. Okay. Right, this was starting here. Yeah. So now, yeah, so we are filtering, right? And then we are creating this new pair with that, and then we will collect the list. So here we are pairing them only if the pair is divisible by 3. So that is our main logic. Otherwise, what we can do is, once we get this list, again we can iterate through that list of pairs and then we can do this filtering. But here, before mapping only, we are filtering out and taking only those pairs whose sum is divisible by 3. So this is the way we can do that, right? Now let's move on to some quickly to some of the functions or methods that are available in Stream, with which we can simplify our operations to some extent, right? If they are useful in our day-to-day coding. So that is nothing but finding something or matching something in a stream. So suppose if you want to check and see if a predicate matches at least one element in that stream. Okay, so suppose if we have a menu.stream any match. So if we are saying, what we are saying is, if there is any dish in this stream that is a vegetarian dish, then just do this operation. Okay, so basically any match is returning a boolean here. Is there at least one element? So here what happens is, as soon as it finds that element, it will stop processing the stream more. Okay, it will not process the entire stream. So as soon as any match, right? So as soon as it gets a match, it will stop processing. Okay, so that is why streams are fast. Okay, they help us with performance. And checking to see if a predicate matches all or none of the elements. Okay, so we want some predicate, nothing but a condition that is fulfilled by all the elements of the stream or none of the elements of the stream. So for that we have two methods, all match and none match. Okay, so we want to check whether all the dishes are less than 1000 calories. Okay, this also returns a boolean, or none of them are greater than or equal to 1000. Okay, this is also a boolean finding of elements in the stream. Finding elements, like if there is any, just like any match, here instead of boolean we are getting an optional. Okay, optional we will discuss more in detail. You can just consider this. So it's basically like a enclosing class of any object that says whether that object is present or not. Okay, for now I think that should be sufficient. Okay, if the object is not there, it will say it is not there. Like it will have methods that say it is not there. If it is there, then it will, those methods will say yes, it is there. Okay, this is just to avoid any null pointer exceptions or null behavior in the code. Okay, so now the any match was giving us boolean, but finding any will actually find that object from the stream. Okay, we are filtering. Then if there is at least one filter, one output of this, then give me that output. If there are no output, that is fine. Okay, if there is any dish that is vegetarian, then return that dish. Otherwise it would be not returning anything. And then finding the first element. Okay, so suppose we have some numbers here, 1 2 3 4 5, and then what we are saying is find the numbers whose square is divisible by 3. Square of this number is divisible by 3. So just as we saw in the quiz, I believe, so we are mapping the number to its square and then filtering out those numbers whose which are divisible by 3. Okay, and then find the first element. Okay, so it's just saying find the first element. You have to maintain the order. Maintain the order of the elements. Okay, so it will take the first element, second element, third element. In that way, it will find the first element that is satisfying this condition of divisible by 3. Here it is 3, right? The 9. 9 is the first square that is divisible by 3. So when do we use find first, okay, and find any? Can you tell me some scenarios where we would need find first and find any? Find any is also basically doing the same thing, right? Like we want any object, we are okay with any object, but find first, we are saying we want the first object. So can you tell me some scenarios where we would use this? Okay, so that is a question for you. So that's it for today's video. It was a little lengthy, I believe, but we have more to cover in streams, which we will be covering in the next videos. So stay tuned and thanks for watching.